This first example today is using the distributive property, so take a look through these. The one weird thing is in example B, they wrote the number after the parentheses. You can rewrite it like this first if it makes your brain feel better. In example C, when you have a variable that you are distributing, remember you have to do that 2x times x and 2x times 4y. And in example D, the negative in front is like a -1 in front. Okay, you don't have this slide in your notes, and we're just going to do this in an example. I would like you to try in example A, combining like terms. See if you can remember what that means. Pause the video. Okay, the 5x and the 2x are like terms. We'd combine those to give us 7x. When you're adding, you do not increase the exponent. So 5x means that there's 5 x's being added together over here. 2x, there's 2 x's being added together over here. Altogether, there are 7 x's. In example B, you've got 12a and -3a. Whatever symbol is in front of the term, attach that symbol to the term. This would then be 9a, -5, and +7 gives us 2. No, I don't want search. To simplify the expression, you have to do either the multiplication, the addition, division, whatever is going on here. So here's a couple of different examples. The first one, we're doing x squared times -2x to the third. They use parentheses here to contain the negative, but really this is just x squared times -2x to the third. So the parentheses don't necessarily indicate distributive property unless there's addition or subtraction inside the distributive or inside the parentheses. Okay, so numbers. We've got a 1 in front of the x squared. 1 times -2 is -2. Then the x's. We've got x squared and x to the third. X squared is that. X to the third is that. How many x's are there total? 5 of them. So this is x to the 5th. When you're multiplying, you add the exponents. Two RS times r squared s. Really, this is 2 times r times s times r squared times s. The parentheses are just containing each term. So multiply the numbers. I see just the 2. The r's, we've got r times r squared. That's going to give us r to the third. And then the s's, s times s is s squared. There's a couple things you can do in example C. You can simplify it first, or you can simplify it later. But it's not always going to work out perfectly like this. So what I do is I just multiply straight across the top, multiply straight across the bottom, and then we'll see what we've got. 5x times 3 is 15x. 3 times 5 is 15. How could we simplify that? 15 over 15, that cancels, and our answer is just x. In the original problem, you could have said the 3 on the bottom cancels out the 3 on the top. The 5 on the bottom cancels out the 5 on the top. We just have x left over. But here's how the problem will probably look on your assignment. Something like 2x over 3 times 3/4, or something like that. So what can you definitely cancel out before you multiply? The 3's. Then you got 2x on top, you've got 4 on the bottom. This portion, 2/4, is a fraction that can be simplified into 1/2, so your final answer would be x over 2. So that's a good extra example that's maybe a little bit more similar to what you might see on your assignment. We need to simplify each of these, and unfortunately, these are not the kind that we can just plug into a calculator. We will have to simplify and remove the symbols of grouping. In example A, we need to distribute the negative 2. So what is negative 2 times 4x? Negative 8x. Negative 2 times negative 1, positive 2, and then we have plus 3x after that. Then combine your like terms. Negative 8x and 3x are like terms, so our final answer is negative 5x plus 2. Example B is a little bit more complex. There's several things going on here. First of all, we have parentheses inside parentheses. We have a grouping symbol within a grouping symbol. We also have negatives in front of our grouping symbols. So just like with order of operations, you're going to start with the innermost grouping symbol. So we're going to start with the 4 minus x. What is directly in front of the 4 minus x? A negative. And remember from before, that's like a negative 1 that we need to distribute. So we would have negative 4 plus x. Now that's just this portion of the problem. So I still need to put the 6 down here. There's another set of parentheses, and there's a 3 minus 2 in front of those parentheses. You don't have to combine like terms at each step, but I'll be honest, it's easier if you combine like terms at each step. So do you see any like terms that we could combine right now? No, not 3 and 2. Why? Why not 3 and 2? 2 is being I didn't want to do that. 2 is being multiplied, and multiplication has to happen before addition or subtraction. So we can't add these two together. That's actually a really, really good point, and I'm glad someone brought it up. You cannot combine the 3 and the 2 because the 2 has to be multiplied before we combine it. So which other set could we combine? The 6 minus 4. The 6 minus 4 is inside the parentheses. There's nothing multiplied inside those parentheses with the 6 and the 4. 6 minus 4 gives us 2. So inside the parentheses, we have 2 plus x. That 2 inside I wrote really big. There we go. Next up, we have a negative 2 in front of the parentheses. I'm going to distribute that negative 2. Negative 2 times 2 is negative 4. Negative 2 times x is negative 2x. That's just this portion of the problem. There's still a 3 in front of that. If that had been a positive 4, you'd have a plus in between the 3 and the 4, but it's a negative 4, so it's a minus. All right, 3 minus 4, negative 1 minus 2x. And here is your 2.2 book assignment.